Welcome everyone, I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 1894, which is find the student that will replace the chalk. So let's see the problem statement. There are n students in a class numbered from 0 to n minus 1. The teacher will give each student a problem, starting with the student number 0, then the student number 1, and so on until the teacher reaches the student number n minus 1. After that, the teacher will restart the process, starting with student number 0 again. Now you have given a 0 indexed integer array which is chalk and an integer k. There are initially k pieces of chalk. When the student number I is given a problem to solve, they will use chalk I pieces of chalk to solve the problem. However, if the current number of chalk pieces is strictly less than the chalk I, then the student number I will be asked to replace the chalk. Return the index of the student that will replace the chalk pieces. So let's see the problem constraints. The length of chalk that is given is up to 10 to the power 5. Each element of chalk will be up to 10 to the power 5 and k will be up to 10 to the power 9. And let's see the one example how to solve this. So we are given a k integer, and each time whenever we are traversing, we will traverse from left to right, and whenever we are traversing, we will check if k is greater than the current index chalk value or not. If it is less than, then we need to return the current index. If it is not, if k is greater than, then we need to subtract the current value from k, and we will go one step forward like that. And if we reaches to the end of the array, then we will again start from 0, the same process. So like this it will be going on. For example, if the k is 12 and all the elements are like this, so in first turn the k will becomes 11 because 5 plus 1 plus 5 is equal to 11. And in first turn, after the pointer reaches the end of the array, the k will become 11. Then in second term also, when the pointer reaches to the end, then k will become 0. Now then that in third turn, when we come, the pointer comes to the first index, which is 0, then 5 is greater than 0. That's why the output is returned 0. Same as here. So all the sum is equal to 3 plus 4 7 plus 1 8 plus 2 10. So in first turn, whenever pointer reaches to the end, the k will become 15. In second turn, k will become 5. In third turn, for the first position, k is 5. Now 3 is less than 5, so it will be subtract from 5. Now the k is 2, and the pointer reaches to the first, like 4 or first index, 1 index. Okay. Now 4 is greater than 2, so we need to return that index which is 1. Like this we need to return. So to solve this problem, we can understand first we need to subtract the the sum of the all elements from k up to how much, whenever the k is greater than the sum, we need to subtract that. So to do that, we will first count the sum of all the elements, then we make a remainder which will be k mod the sum, because we need that, because that could be k maybe multiple of the sum or may not be. So we will take the remainder, and then using that remainder we will start from the first index. That means we know in one turn, one single turn, the remainder will be we can find the that index when the remainder will be less than the current index, because in one term because the remainder will always be less than the sum. Okay. So that's how we will solve this problem. So first, and you can see the constant. If in worst case the length is 10 to the power 5 and all the elements are 10 to the power 5, then the sum of all the elements will be 10 to the power 5 multiplied by 10 to the power 5, which is 10 to the power 10. That we can't store in integer data type, so we will use long data type to store the sum. So first long sum equal to 0. Now for each of the elements, auto iterate in chalk sum plus equal to it. Now we got the sum. Now we will calculate the remainder. To calculate the remainder, let's say first, let's say kk, or the remainder is initially k, and we will mod the mod equal to the sum. Now the remainder is less than sum, and we will start from the first index. So for int I equal to 0, I less than chalk dot size plus plus. We will check if chalk of I is greater than the remainder. Then we will return the index, current index, which is I. Otherwise, we will subtract that the current value, which is chalk of I, from the remainder. That's it. And we know there must be one index where the remainder is less than the current value. So we can return anything here. So return just -1 or anything. And here, as the chalk of I is an integer value, just to make it long, because the remainder is a long data, right? So just to make it long, so use the explicit typecasting. And now let's see, will it work or not? There is an error which is not LL, it will be long. My bad. So it is accepted. Let's submit it. So it is accepted. Let me discuss the time and space complexities of this algorithm. To calculate the sum, it will take big O of n time complexity, and we are again traversing the whole array to find that index. So the overall time complexity will be big O of n, and the space complexity will be big O of constant, because we are not using any array or list which is depending on the length of chalk. So we are just using some variables. So overall time complexity, overall space complexity will be big O of constant, or you can say big O of 1. So thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.